Now, let us see the different components of a memory structure in Java. So I'm going to draw them sequentially. First comes the method area. I'm just going to call them MA. Second comes the heap area. I'm just going to call them HA. Third comes the stack area. Fourth comes the PC registers. Let's say it's going to be for thread 1, thread 2, and so on. And at last comes the native method stack. I'm just going to call it native MA. MA stands for method stack. Now let's see each one of them one by one. So first comes the MA. Method stack. So what does it do, method stack? It stores a couple things. For example, whenever JVM starts up, this memory stack is created. And in this stack, this is shared among all the threads which are going to run inside that JVM. All right. So for example, it is used to store class structure or superclass name. For example, whenever you say, let's just say you define a variable, say name is equal to John. So whenever you define this name equals to John, you don't define it like this. Let's say you just say public static string name, right? So when you say public static string name, where does this thing goes? So there is a memory stack known as method stack. In this method stack, string would be stored. Its access modifiers, which is public, this will be stored here on that method stack as well. Or what is the superclass of this string? Let's just say it is superclass as java.lang.object. So this will be stored here as well. So in method stack, name of fully qualified of a type will be stored, access modifiers will be stored, the name of this superclass will be stored, things like that, or name of the interfaces which this thing inherits will be stored here in method stack. All right, so let us move on to heap memory, which is known as heap area. Next comes the heap area. What does it do, why it is there, and what it exactly stores? Whenever JVM, which is Java Virtual Machine, starts up, this guy right here, heap area, this gets created. What it stores is the actual object. So whenever you write, for example, string name is equal to John. Let's just say this, you write this sentence in your Java program. So what Java does is use this name and store it into a stack. This name you see is called as a reference variable. Okay. Now heap, let's just suppose this is our heap. Now when you say string name equals to John, a memory area will be created of the type string. All right, it will store your John. And this John right here is your actual memory allocation for this reference variable name. Now, where does this thing get stored? Name. Now, there is something known as stack in Java. In stack, Let's just say this is filled up for something else. And whenever we say string name equals to, the name gets stored in the stack. This is our stack. And whenever you say name is equal to John, so John here, the memory location here will be created, which will store the data of the type string, and the value will be John, and the name will point to this. So whenever you write sentence like this, string name equals to John, or maybe you write int x is equals to 10. So this thing is not an object. This is just a reference variable. And repeating again, this is not an object. This is a reference variable. This will point to an object. If you write here is equals to 10, this 10 here will be stored. And another object will be created on top of this is x, and this will point to here. Now, imagine if you write int, let's just say x is equals to 101. Now, what will happen? Does this thing create another x object? No. What it will do is it will reassign this thing to new object. It will create new object as 100. It will assign this, and it will discard this arrow. So now the memory gets freed. The memory which used to store 10 is now free. And now x is pointing towards another new memory location, which stores 100 of the type integer. All right. So now what will happen to this? Now I'll tell you. Now this becomes eligible for our GC, garbage collection. So whenever Java thinks that their memory is getting full, it will run a garbage collector on this. Now it will see that no one is pointing to this 10 object. So what it will do, it will just erase this. It will just clean this up. Our garbage collector cleaned this up. So because no one was pointing to this object. If you do string, or not string, sorry. If you know name is equal to null, let's just say the name used to store John first. Now you have assigned this, and say that I want name variable to point to nothing, to be honest, to point to nothing. So this will erase this pointer. Java does not have pointer. I'm just using it as a layman term. All right. So this name will now point to nothing. So this remains in stack. This remains in heap. But this again becomes eligible for garbage collection. Now, whenever Java feels that again memory is getting full, it will run again GC on this heap memory, garbage collector on this heap memory. Now it will see that nobody's pointing to John. So it will just clean this up again. So that's how a basics of your Java memory management works. Now, I'm going into the details how heap area has different and several paths. Now, whenever we say heap memory, we already know what it does, how it works. Now, let us say how many parts the heap memory is divided. First is young gen or young generation. Next comes survivor, space. Third comes old gen or old generation. Fourth comes perm gen or permanent generation. And at last comes the code cache. Now there are different levels of heap memory. The young generation, where the object is created very recently, and this gets older and older as you go down to next generation. You can think of this like a child of like 1 year old, and this is like the old age home. Now, once we will get to this thing later on in our later lectures, when I will give you in hands-on, and I will tell you where exactly can we see this thing gets working? So we will skip this for now. Once we have a idea of stack, PC registers and native MA, then we will come back to this survivors gen, because this needs the knowledge of all this to understand this. Now let's talk about our stack area. Remember that last part when I talked about there's a heap memory, and whenever you write something like string name is equals to John, the name will be stored, the actual name John will be stored on this heap area, but on when we talk about stack, this name, this and this will get stored on our stack. So it stores reference variables only from the sentence. Sometimes it can hold value itself rather than the a reference to an object from the heap. I'll tell you later on when it happens. The stack area is not generated whenever JVM starts, or rather this area is generated, stack area is generated whenever the thread gets created. It can be either of fixed size, or it may be of a dynamic size, dynamic array. So this is just the overall work of stack area. Now we will move on to next PC registers. We don't have to go deep down into the PC registers because it's not so important. We will just have a look at them. Next comes the PC registers. Now this PC stands for not what you think of, it's not personal computer, it stands for program counter. I'm just gonna write it down for you. So what does a PC register have to do, or what does program counter have to do with JVM or Java memory management thingy? So each thread that has a program counter register associated with it, a PC registers or program counter registers stores the return address of the pointer. Okay, so it also contains the address of what JVM instructions tell the PC register to do, or what JVM instruction currently is executing, or what thread the JVM has currently executing. It also stores that information. So this was the entire thing for Java memory structures. Now we will go to the second part of our introduction, which is garbage collection, and how garbage collection works on all of these, especially on heap area, where we talked about young gen, perm gen, and old gen, hard. Now second comes the garbage collection. Apologies for that. Or I'm just gonna call it GC for short. Now what is the main thing of garbage collection? So let's, in simple words, when a program starts in Java, let's say abc.java, when this thing runs on our JVM, it takes memory. It takes memory to execute. It takes memory to store. Now the heap is a part of memory where objects live. Okay. And that heap area is only the part of the memory where garbage collection operates. You can think of it like our municipal corporation. This makes sure that more and more space is available, more and more heap. This is our HA, heap area or heap memory. This thing makes sure that this thing gets cleaned up every once in a while. So technically speaking, I've already told you when garbage collection works. So whenever you write something like integer x is equal to 10, there is this stack which stores the variable name, which is x, and here a memory is allocated and then will reside here of the type integer, and x will point to this. I've already told you this. Now if you write x is equals to null, this reference is erased. All right, this reference gets erased. There's nobody now pointing to this. Now once in a while, when garbage collection runs on this entire heap area, it will check in the entire heap area that if there is any object which cannot reachable or which has no reference to it. In this case, after this line executes in our program, the garbage collection can see that this is something which is lying around here and has no pointer, or not pointer, or we can say there is no reference to it, or it is not reachable, so it will just delete this memory. So this is the only thing garbage collection do. So the question arises, who controls the Java garbage collector? Now the parent of that guy, garbage collector or GC, is JVM. JVM thinks or decides when to run this Java collector, or garbage collector on our heap memory, but there's no guarantee under any condition that JVM will comply. It's like JVM runs this Java collector when JVM thinks that memory is getting low and something needs to be done. It's like your mobile application where you have like a RAM booster and you click on that RAM booster and your RAM gets freed up. It's exactly like that. It works exactly like that. But later on in this course, we will see how to run this garbage collector manually. We can also call this garbage collector. There is a static method available known as GC. Now this GC comes under system, a predefined class. So whenever you call system.gc, garbage collector executes. Now in next video or a couple of videos later, we will see how this will impact our memory, and we will also physically see when our program runs where and how it occupies the memory. But before that, let me explain the young generation, the perm generation, or the heap memory in detail.